Hi everyone, welcome to lecture 14 on basic inorganic chemistry. My name is Dr. Teresa Chimambam. For today's lecture, we will cover volumetric analysis and specifically acid-base titration. What is volumetric analysis? We use volumetric analysis to determine the amount of any given substance by carrying out titration. So what this means is that titration is an example of volumetric analysis, and it can be acid-base titration. So what is titration? Titration is a controlled addition of a solution of known concentration to a solution of unknown concentration but known volume containing 2 or 3 drops of an indicator until a color change is obtained. So what this means is that whenever you are carrying out titration, there must be a solution of known concentration and there must be a solution of unknown concentration, which will be the one that you will be analyzing. So you then simply add a solution of known concentration to the solution of unknown concentration until you obtain a color change. When analyte is a base or an acid, and the titrant is an acid or a base, then the titration is known as acid-base titration. So we now look at some of the important terms that you will be coming across whenever you are doing volumetric analysis. So the first is titrant. What is a titrant? A titrant is a solution of known concentration. So a titrant is a solution that you know the concentration. So it is very easy to remember. Another important term that we use in titration is analyte. What is an analyte? An analyte is a solution that you are trying to determine the concentration because you do not know the concentration, but you know the exact volume. So an analyte is a solution of unknown concentration but known volume. So analyte will be the one that you will be analyzing. While titrant is the solution that you know the concentration, and that's the solution that you will be adding to the analyte. Another important term that you will always come across whenever you are doing acid-base titration is endpoint. What is an endpoint? Endpoint is when the color of the solution you are titrating changes color. And the color it changes to depends on the indicator that you have used. So endpoint is the point during titration when the color of the solution changes color. Another important term that you must be familiar with is equivalence point. What is an equivalence point? Equivalence point is the stage in titration when the number of moles of acid is equal to the number of moles of base. So at equivalence point, the number of moles of acid is equal to the number of moles of base. So if you are asked the difference between endpoint and equivalence point, the major difference between them is that equivalence point happens before the endpoint. So equivalence point happens before the endpoint, while endpoint signifies the end of the titration. So whenever you reach the end point of your titration, that is when you obtain the color change, you stop the titration. So at equivalence point, the titration has not stopped, but at end point, the titration is stopped. So titration is completed when enough titrant has been added to the analyte, and you observe a color change. So that color change is called endpoint. And at this point, we already know the meaning of analyte. Analyte is the solution you are analyzing. Because you do not know the concentration, you only know the exact volume. While titrant is the one that you know the concentration, which you will add to the unknown concentration that you are analyzing. Right, so we now look at other titration terms that you need to be familiar with whenever you are carrying out titration. So the next one is standard solution. What is a standard solution? A standard solution is a solution which you know exactly the concentration. So any standard solution is a solution of accurately known concentration. So it is very easy to remember. Another one is called primary standard. What is a primary standard? A primary standard is used for preparing standard solutions. So we use primary standards to prepare standard solutions. An example of a primary standard is sodium carbonate. So a standard that is made in the lab for a particular analysis is called secondary standard. So we prepare secondary standard in the lab and we use it for a particular analysis. So a secondary standard is normally standardized against a primary standard, and we prepare secondary standard in the laboratory. And a secondary standard is used for any particular analysis. Now we look at indicators, and we can represent indicators with the letter HIN. So indicators are weak acids and they dissociate as an acid in this way. So this is the indicator. It will dissociate like an acid, which it is because it is a weak acid, and when it dissociates, it will form hydrogen ion plus a negative ion. So indicators help us to get an endpoint when carrying out titrations. So with the help of indicators, we can get the endpoint of our titration. It makes it possible for the color of the solution to change depending on the pH of the solution. So without adding an indicator during titration, there will be no visible color change in the solution when enough of the acid has been added to the base to neutralize it. So what it means is that there will be no visible change at the end point if we do not add indicator. So the end point is commonly detected in an acid-base titration by adding an indicator. So an example of indicator is phenolphthalein, and this is the general formula. This is how it looks like. It comes in a bottle like this, and it has a dropper that you can use to drop in your solution. So this is the structure of phenolphthalein. So phenolphthalein is commonly used as an indicator when we are carrying out acid-base titrations. It turns colorless in acidic solutions and pink in basic solutions. It changes color due to the pH of the solution. So it has a pH range at which it changes color. So these are other common indicators. So like I said, phenolphthalein is commonly used. So colorless in an acid. This is the pH range for color change between 8.2 and 10. And the color in base is pink. Methyl orange is another example of indicator. In an acid, it is red. This is the pH range at which it changes color between 1.2 to 2.8, and its color in base is yellow. Phenol blue is another type of indicator. It is yellow in acid. The pH range for color change is between 8 and 9.6, and is blue in base. Bromocrystal green is yellow in acid. The pH range is between 3.8 to 5.4. This is the pH range for color change, and it is blue in base. So these are some of the examples of common indicators that we use for titrations in the lab. So now we look at pH. What is pH? pH helps us to know the acidity or alkalinity of any solution. So pH helps us to know the acidity or alkalinity of a solution. pH estimates the hydrogen ion concentration of a solution. So it helps us to estimate the hydrogen ion concentration of a solution. The pH scale usually ranges from 0 to 14. The acidic part is 1 to 6, 7 is neutral, and the basic part is 8 to 14. Right. The formula used to calculate the pH of any solution is pH equal to minus log H ion concentration. So this is the formula used to calculate the pH of any solution. Notice the negative sign here, so it is important that you do not miss it. And the square bracket means concentration in mole per dm cube. So this hydrogen ion in square bracket means concentration in mole per dm cube. And this hydrogen ion in square bracket also indicates the acidity of the solution. Right. After carrying out titration, we obtain titer values. Titer values are simply the volume of the titrants that you have added to the analyte. So we present the titer values in a table as I have shown here. So you have rough, first titration, and second titration. The rough titration is used as a guide so that you know where the end point lies, so that when you are carrying out the first titration, when you are getting close to the end point, you start adding the analyte drop by drop. So you write here initial burette reading in milliliter. It is either in milliliter or cm cube. So it is important for you to put the unit. If you do not put the unit, whenever you presented any titration results, you will lose some marks. Once you put the unit here, you don't need to put here again. So final burette reading in milliliter, volume used in milliliter, average titer in milliliter. So if your initial burette reading was 0, final burette reading 14.4, so volume used in milliliter would then be difference between the two, 14.40. For your first titration, if you started from 14.40 and the final was 28.40, the difference between the two would then give you the volume used in milliliter 14. So the same thing is applicable here. So to get your average titer value, you simply add the first and second volume used and divide by 2. So you find the average of the first and second titer values. As I said earlier, you do not need to add the rough titer value because it was simply used as a guide. So once you obtain your average titer value, you then use this formula to calculate the unknown concentration. So this is the titration formula. MAVANB is equal to MBVBNA. This MA is molarity of acid, VA is volume of acid, NB is number of moles of base, MB is molarity of base, VB is volume of base, Na is number of moles of acid. So this is the formula that we use to calculate unknown concentration after carrying out titration. Right, so this is where I'm gonna end for today's lecture. Please like this video and subscribe, and I will see you in the next lecture.